In this video, I'm looking at solving quadratic equations using the various techniques, and I'm going to go over the quiz that I gave in order to do that. There were two versions. Okay, the first question you were supposed to solve by factoring. Okay, so whether you're doing factoring or the quadratic formula, you need to get everything equal to 0. So I'm going to subtract 18 from both sides to get that to be the case. Once I do that, what I'm going to think about is that expression would have come from two binomials. Whatever's in the first spot would have to multiply to be x squared. Whatever I put at the end when you FOIL things out would have to give you 18. So now I'm going to think about 18 and the fact that there's a lot of possibilities for 18. Not a lot, but there's several possibilities. You can, on this one, look at the fact that nothing is being contributed. There's a 1 in front of the x squared, so nothing is contributing to the middle term from there. So you really are just looking for factors of 18 that could potentially give you a 7. So that seems like 2 and 9 would work. So put those in. And then think about when you FOIL out, how when you multiply the inside 2 and the outside 2, those have to combine to give you that middle term. So the 9 would need to be negative and the 2 would have to be positive. Okay. Now, once you do that, you've got it factored, just FOIL back out, make sure everything's good, that signs are all right and everything. So do a quick refoiling. There's your x squared. Okay, then you've got your 9x that's negative plus a 2x that's positive. That gives you the negative 7x. And then when you do the last two, you get a negative 18. So all's good. All right, now once you know it's correct, then you set each factor equal to 0. And then I could subtract 2 from both sides to get x equals negative 2, add 9 to both sides, and that's going to give me x equals positive 9. Okay? All right, so on the other version, you would have done the same thing to start with. Subtract 14 from both sides. Okay, then work on factoring. So for 14, I'm going to use a 2 and a 7 rather than a 1 and a 14 because I know I'm trying to get a 5 in the middle, and I want the 5 to be negative, so I'm going to make the larger one negative. I FOIL that back out, make sure that I'm correct, and once I know I'm correct, I set each factor equal to 0 and solve. Okay. Oops. So subtract 2 from both sides, and I wind up with x equaling negative 2, so add 7 to both sides, or x equals 7. Okay, so by factoring. All right, the next two problems I asked you to solve by using the quadratic formula. So you need to know your quadratic formula. Okay. All right, and then you're gonna make sure it's equal to 0 like it is, and everything's in order. Once you've done that, you're gonna identify your A, your B, and your C. Okay. Then you're going to plug into the quadratic formula. So you're going to do the opposite of b, plus or minus square root of the b squared minus 4 times a times c. You're going to divide that all by 2 times a. Okay. Then at that point, you're going to do a little simplifying. So we have a negative 4 there and an 8 at the bottom. And then under the radical, 4 squared would be positive 16, and a negative times a negative would be plus something. And then we just got to do the 4 times 27, which is 432. Okay. Then you combine the 16 and the 432, and you get 448. Okay. Now at this point, I keep asking everyone to be sure to show all their work, including simplifying the radicals. So you'll need to show me that you know how to do that. So you take your 448, start breaking it down. I noticed a 4 would go into there, and it went in there 112 times, and then 4 goes into that, I noticed, and so I divided 4 into that, and it went 28 times, and then in fact 4 would go in there 7 times. So I wind up with the one way to break it up. This isn't the prime factorization, but I noticed 4 went into there a bunch of times, and I wanted to just go ahead and leave that because remember you're taking the square root. So the square root of all of that would be square root of 4 times square root of 4 times square root of 4 times square root of 7. So we get a 2 times another 2 times another 2 times square root of 7, which gives us 8 square root of 7. And 8 square root of 7 is going right there in place of the square root of 48. So we do that. And then sometimes at that point you're finished. But here, do you notice that 4 would go into all three of those numbers? 4 is a factor of that numerator. The idea is that we could factor out the 4 from the numerator. If we did, we'd have a -1 left in that first spot, then plus or minus 2 square root of 7. And then down here we can say, all right, well I know 4 goes into 8 twice. So your final answer on this would be -1 plus or minus 2 square root of 7 over 2. Right now, from this point right here, where you have -4 plus or minus 8 square root of 7 over 8, okay, what a lot of times we'll do is just divide by 4 in all three spots and get a -1 plus or minus 2 square root of 7 over 2. So some of us do that as well. Okay, so let's try another one of those. Okay, so here the A is 4, the B is 4, and the C is -11. So the solutions would be found by doing the opposite of 4 plus or minus square root of the 4 squared minus 4 times -11, all of that over 2 times 4. So we're going to have a -4 and an 8. Under the radical, we're going to have a 16 plus something, because a negative times a negative would be plus. And then 16 times 11, I don't know what that is. Let me see, where's my work on that one? I don't have a calculator in front of me. Let me just find that version. I think it's 176. Well, let me just do it. I don't have my calculator handy, but isn't it 176? Yeah, it's 176. So underneath the radical, we have 16 plus that. So that would be 180, 192. And then we've got to break down 192. Okay, let me do this one using prime factorization, just in case you're doing that. So it may not be obvious what goes into 192 evenly. So you see it's even, so you know you can divide by 2. 2 would go in there 96 times. Okay, then I could do that again. 2 would go in there 48 times. Okay, and I could keep on with that if I wanted to. Okay, so here that would be 2 times 24. That would be 2 times 12. I don't like all these 2's because it makes it very one-sided. So personally, I don't necessarily do it that way. I would have probably stopped when I saw the 48 because I know that's 16 times 3. But now look, we've got 1, 2, 3, 4, 5, 6 2's and a 3. Okay, so it's 6 2's and a 3, and we're trying to do the square root of that. So every 2 of them is going to be a perfect square, and when you do the square root of each of those, you're going to get a 2, and then the 3 would be trapped still underneath. So we get 8. That would be 8 square root of 3, plus or minus 8 square root of 3. Okay, and then we would simplify one of those 2 ways, similar to what we did here and here. So if you divide by 4 everywhere, you'd get -1 plus or minus 2 square root of 3 over 2 for your final answer. Okay, all right, now that one was using the quadratic formula. Okay? Now the square root method is the next one, and I think some of the problems with a lot of our problems have to do with some basic algebra skills that you need to be reminded about. So when you're trying to like unwrap this and get the x by itself by using the square root method, you can't jump right in and take the square root right off the bat. you need to have the square root part isolated. It's kind of based on order of operations. If you just look at one of these, if I put a number in here for x, for instance, on the one on the left, I would have added 2, okay? Then I would have squared, okay? Then I multiplied by 3, then I subtracted 4, okay? So it's kind of like our work with inverses, okay? We need to reverse that. We need to go backwards there. Like, so I'm talking about taking those steps and just reversing them. So the first thing I'm going to do is add 4 to both sides. Then I would get a negative 27 on the right, okay, equals 3 times that quantity squared. All right, if you had tried to divide by 3 first, the 3 would have to knock this out, also divide into the 4, and also divide into 31. So I think sometimes we're just not unwrapping this in the correct order. Okay, so think about the steps that you would do if you plugged a number in there, and then you've got to try to reverse those. So I'm added 4. Okay, so that one's done. Now the opposite of multiplying by 3 would be dividing by 3. Okay, so that's going to give me the x plus 2 quantity squared equals negative 9. Okay, now to undo squaring, I'm going to square root. When you do, make sure that you think about how there are 2 square roots to any number. Okay, so you need a plus or minus out in front of that. Now you did the square root because it undoes squaring. So that's going to be x plus 2 equals plus or minus 3i. All right, so that undid this part, the squaring. Now I've got that plus 2 to get rid of. So to get rid of that, I'm going to subtract 2 from both sides. Now when you do subtract 2, okay, this is the best place to put it. Kind of think about the quadratic formula and where things would show up. So x would equal negative 2 plus or minus 3i, and those are not like terms, so you can't combine it in any way. Now, if you had written plus or minus 3i minus 2, that's equivalent. It's just this is the usual form you would leave it in, because that's in the standard form for a complex number. Okay, so let's try another one. All right, so we're going to add 4, which gives us a negative 12 on the right. Okay. All right, then we're going to divide by the 3. So when we do that, we wind up getting a negative 4 on the right. Then we're going to take the square root of both sides. Which gives us x plus 1 equals plus or minus 2i. Okay. And then I'm going to subtract the 1 from both sides and get x equals negative 1 plus or minus 2i, and I'm done. Okay. Right, and then on the last problems, I said you could solve it either way. The only two that would make sense would be either factoring or the quadratic formula. So I'm going to show factoring on this one, and I'll show the quadratic formula on this one. Okay. And then we'll do another example of each. So for the quadratic formula or factoring, you would need to get it all set up, right, so that you have a 0 on one side. So that would become 2x squared plus 15x minus 27 equals 0. All right, if you're using factoring at this point, there's no common factor, so I'm going to try breaking it into 2 binomials. So I would need a 2x and just x multiplied together to get 2x squared. At the end, I've got a lot of possibilities, so it makes it a little harder because 27 could be 1 and 27, 3 and 9. I'm going to try the 3 and the 9 because I normally do that when the middle number isn't that big. So I would mess around a little bit here. If I put the 9 here and the 3 there, that looks like a good candidate at first, maybe a possible candidate because my inside term comes from these and there's a way to make 15, but if I use that, they would both need to be positive. Okay, And here I have a negative in front of the 27, so that can't be the case. I'm not going to abandon the 9 and the 3, though. I'm just going to try flipping it around before I leave it. What if I put it that way? Then I would have an 18x here, and I would have a 3x there. That can also give me 15x, but I'd need a positive on the 18 and a negative on the 3. So I would need a negative there and a positive there. Okay. Now, once I've FOILed it out and made sure I'm correct, then I'm going to take each of those factors and I'm going to set them equal to 0. So I'm going to take 2x minus 3 equals 0, and then x plus 9 equals 0. So one of my answers would be negative 9. The other one, after I add 3, I would get 2x equals 3, and then when I divide by 2, I'd get 3 halves. So 3 halves and negative 9 would be my two answers. Okay, so that was done using factoring. All right, for the quadratic formula, if you approached it that way, you would have still had to add 15x and subtract 27. Then you would have plugged into the quadratic formula. So it's the opposite of 15 plus or minus square root of the 15 squared minus 4 times 2 times negative 27. All of that over 2 times 2. Okay. All right, so that would be a negative 15 on top of 4 down here. Underneath the radical, 15 times itself is 225, and then 27 times 8 would be 216, and it would be plus 216 because there's a minus and then another negative. Okay, so that's going to give me negative 15 plus or minus square root of, and that's 441 over 4. Okay, now let me go over here with it. I'm running out of room. So that would equal negative 15 plus or minus 441 is 21 times 21. So plus or minus 21 over 4. I'll move this down a little. Okay, and then you need to split it up. Okay, you need to think it equals either 15 plus 21 over 4, or it equals 15 minus negative 15 plus 21 over 4, or negative 15 minus 21 over 4. This would be the negative 36 over 4, which gives you the negative 9. This first one would give you a positive 6 over 4, which is where the 3 halves would have come from. Okay. Okay. All right, so let's try on this last one. Let's do it both ways. So factoring, I would add 11x and subtract 21 to get it equal to 0. Then if I'm factoring, I would be thinking 2x times x. 21, I only have the choice of a 1 and a 21 or a 3 and 7. I would try the 3 and the 7 first. So on this one, if I put the 7 here and the 3 there, I would get a 7x and a 6x. So that could be 13, but there's no way to make it 11. So I'm going to try flipping it around. And I'm going to put the 7 there at the end and the 3 in the first set of parentheses. Then I get a 3x and a 14x, which I can make be 11 if I make the 3 negative. All right, now once I've FOILed it all back out, made sure all the signs are correct, which they would be, then I'm ready to set those factors equal to 0. And so one of the answers is going to be negative 7, and the other answer would be a positive 3 halves, because I'd add 3 and then divide by 2. All right, and then if we're doing the quadratic formula, we would again have to get it equal to 0, and then we'd plug into the quadratic formula. Okay. So we'd have negative 11 plus or minus square root of, this would be 121, and then a negative times a negative would be plus something, and it's 21 times 8, so that's 168. 8 and 16, yeah, over 4. So that's going to equal, let me shorten that a little bit. So that's going to equal negative 11 plus or minus the square root of 289, 89 over 4, which is negative 11 plus or minus 17 over 4. And then you do the two possible answers. So it's negative 11 plus 17 over 4. Okay, that's one of them. The other one would be negative 11 minus 17 over 4. So negative 28 over 4. 28 over 4, which would be negative 7. And over here we get 6 over 4, which is 3/2.